Hi class, today we're going to talk about section 6.4 rectangles, and our objectives today are to recognize and apply properties of rectangles and to determine whether parallelograms are rectangles. So let's go ahead and get in some information about rectangles, and once we know all of this, then we're going to be able to put it into use. So a rectangle is a parallelogram with 4 right angles. We know that right angles are in rectangles. Since a rectangle is a parallelogram, then a rectangle also has the following properties. So think back to your 6.2 through 6.3 parallelogram property of parallelograms notes. Opposite sides are both parallel and congruent. Opposite angles are congruent. And consecutive angles, those are the ones right next to each other, those are supplementary. And then lastly, our diagonals bisect each other. So remember, bisect means it cuts it into 2. One last piece we're going to add with that is, in addition, in a rectangles, the diagonals are congruent. So diagonals are congruent. So what that means here is that JL is congruent to MK. And when they bisect each other, then that's going to make a difference too. So if you put in a point P on there, we are going to be able to say that JP is congruent to PL, excuse that, and then MP is congruent to PK. All right, so let's go ahead and put that to use. A rectangular park has 2 walking paths as shown. So take a look at that. Those walking paths go from corner to corner, so that creates diagonals. If PS is 180 meters, that's going to be this whole side, and PR, this diagonal, is 200 meters, find QT. That's our portion right there. Well, if we look here, that 180 has nothing to do with our diagonal for us. So we know our diagonals bisect each other and are congruent. So I'm going to know that my green is going to be also 200. And if it's bisected, I know that QT is going to be equal to 100 meters. All right, I want you guys to use the information above about the rectangular park and find PR if you know what TS is. So let me go ahead and clean up that diagram for you. If TS, this portion here, is 120, find PR, which is this whole portion here. I know that you guys can have that done for me for tomorrow. All right, so then that jumps to the back side. It says quadrilateral JKLM is a rectangle. If measure of angle KJL is 2x plus 4, and the measure of angle JLK is 7x plus 5, find x. Well, if I look here, I've just outlined a triangle. We know that some different things about angles with triangles, and that all 3 angles are going to equal 180 degrees when I add all 3 up. And I know if this is a rectangle, which it tells me that that's a 90-degree angle. So I can go ahead and I can add all 3 angles together and solve for x. That's an easy enough one for you guys to come back with for tomorrow. All right, here comes the tough one. Quadrilateral PQRS has vertices as given. Determine whether PQRS is a rectangle by using the distance formula. So here's our hint. Find the length of each side, and we know that opposite sides must be congruent. That was our parallelogram property. And then find the length of the diagonals. Those must also be congruent. That makes this a rectangle. So it seems like we're going to do distance formula 6 times here. But at least I tell you which 2 points to go through to find it. You can graph this, definitely, if you ever are just given the points and you know what the sides are and what the diagonals are. All right, so let's go ahead here. Our first one we're going to set up is PG. And so I have -1 minus 3 and then squared equals, oops, not equals, plus 1 minus -5 and square that. 1 minus -3 gives me -4. -4 squared is 16. I have minus a negative. Can I change that to plus positive? 1 plus 5 gives me 6. 6 squared gives me 36. If I go ahead and add those, I get the square root of 52. Take a moment, type in square root of 52 on your calculator. I got 7.2. Did you get the same thing? Good. All right, RS. So we're going to do 0 minus -4, square that, plus -7 minus -1, square that. Got some minus negatives, I can change to plus positives. So 0 plus 4 gives me 4. 4 squared gives me 16. -7 plus 1 gives me -6. -6 squared gives me 36. If I add those, I get square root of 52. And we already know square root of 52 is 7.2. All right, go ahead and finish finding the other two sides and the diagonals. We've already got a good start, and 2 of the sides are equal, or congruent, so that's a good sign for us. So go ahead and finish that up for tomorrow. Lastly, using the Pythagorean theorem, quadrilateral WXYZ is a rectangle. So we know it's a rectangle. If XW is 3, and WZ is 4, and XZ is C. Find C and WY. Well, that's easy enough. We can see right here we have a right triangle, and we know to find the third missing side for a right triangle, we're going to go ahead and use our Pythagorean theorem. And my diagonal across from that right angle is going to be my hypotenuse. So I know I'm going to do 3 squared plus 4 squared equals C squared, my hypotenuse. So 3 squared gives me 9, 4 squared gives me 16, C squared. If I add those, I get 25 equals C squared. Square root of 25, to get rid of that squared, and C equals 5. So if C is 5, and then it asks us for WY. Well, WY, if we look here, is my other diagonal. Think about what was one of my rules about rectangles. Well, the thing that differs rectangles from parallelograms is that rectangles, diagonals are congruent. So I know that it is also 5. All right, guys, we'll see you guys tomorrow with the rest of these notes completed.